Place value, 5 hundredths. 5 hundredths is written in the second place after the decimal point. Since there are no whole units, we write 0 before the decimal point. Since there are no tenths, we write 0 in the tenths place. Then we write 5 in the hundredths place. So, 5 hundredths is written as 0.05. Place value, 1/10. 1/10 is written in the first place after the decimal point. 1/10 means 1 part out of 10 equal parts. So, 1/10 is written as 0.1. Place value with thousandths. The number 7 and 7 thousandths includes the thousandths place. Thousandths are written in the third place after the decimal point. Here, the whole number part is 7. There are no tenths, so we write 0 in the tenths place. There are no hundredths, so we write 0 in the hundredths place. There are 7 thousandths, so we write 7 in the thousandths place. So, 7 and 7 thousandths is written as 7.007. Writing 23 hundredths. 23 hundredths means 23 groups of 100. To find the number, multiply 23 by 100. 23 times 100 equals 2300. So, 23 hundredths is 2300. Writing 23 tens. 23 tens means 23 groups of 10. To find the number, multiply 23 by 10. 23 times 10 equals 230. So, 23 tens is 230. Writing 234 tenths. 234 tenths means 234 divided by 10. Since 10 tenths make one whole, we divide by 10. 234 divided by 10 equals 23.4. So, 234 tenths is 23.4. Writing 234 hundredths. 234 hundredths means 234 divided by 100. Since 100 hundredths make one whole, we divide by 100. 234 divided by 100 equals 2.34. So, 234 hundredths is 2.34. Writing 105 tenths. 105 tenths means 105 divided by 10. 100 tenths make 10 whole units. The remaining 5 tenths make 0.5. So, 105 tenths is 10.5. Length conversion, centimeters and millimeters. 1 centimeter is equal to 10 millimeters. That means 1 millimeter is 1/10 of a centimeter. 1/10 written as a decimal is 0.1. So, 1 millimeter equals 0.1 centimeter. Convert 5 millimeters to centimeters. To convert millimeters into centimeters, divide by 10. Since 1 millimeter is 0.1 centimeter, 5 millimeters is 5 times 0.1 centimeter. 5 times 0.1 equals 0.5. So, 5 millimeters equals 0.5 centimeters. Convert 12 millimeters to centimeters. 10 millimeters make 1 centimeter. So, 12 millimeters can be split into 10 millimeters and 2 millimeters. 10 millimeters is 1 centimeter. 2 millimeters is 0.2 centimeters. So, 12 millimeters equals 1.2 centimeters. Convert 5.6 centimeters to millimeters. To convert centimeters into millimeters, multiply by 10. Each centimeter has 10 millimeters. 5 centimeters is 50 millimeters. 0.6 centimeter is 6 millimeters. So, 5.6 centimeters equals 56 millimeters. Fill in the blank, 70 millimeters. To convert millimeters into centimeters, divide by 10. 70 millimeters divided by 10 equals 7 centimeters. So, 70 millimeters equals 7 centimeters. Fill in the blank, 0.9 centimeter. To convert centimeters into millimeters, multiply by 10. 0.9 centimeter means 9/10 of a centimeter. Each tenth of a centimeter is 1 millimeter. So, 0.9 centimeter equals 9 millimeters. Fill in the blank, 134 millimeters. To convert millimeters into centimeters, divide by 10. 134 divided by 10 equals 13.4. So, 134 millimeters equals 13.4 centimeters. Fill in the blank, 203.6 centimeters. To convert centimeters into millimeters, multiply by 10. 203.6 times 10 equals 2036. So, 203.6 centimeters equals 2036 millimeters. Very small real-life measurements. Some real-life things are very small. Hair, paper, seeds, ants, and snails can be measured in millimeters. Decimals are useful because many objects are smaller than 1 centimeter. For example, a human hair may be about 0.1 millimeter thick. So, decimals help us describe very small measurements more accurately. Meter and centimeter conversion. 1 meter is equal to 100 centimeters. That means 1 centimeter is 1/100th of a meter. 1/100th written as a decimal is 0.01. So, 1 centimeter equals 0.01 meter. Convert 10 centimeters to meters. To convert centimeters into meters, divide by 100. 10 centimeters means 10 over 100 meters. 10 over 100 is 0.10, which is the same as 0.1. So, 10 centimeters equals 0.1 meter. Convert 15 centimeters to meters. 15 centimeters means 15/100ths of a meter. So, write 15 over 100. 15 over 100 is 0.15. Therefore, 15 centimeters equals 0.15 meters.
Fill in the blank. 36 centimeters. To convert centimeters into meters, divide by 100. 36 divided by 100 equals 0.36. So 36 centimeters equals 0.36 meters. Fill in the blank. 50 centimeters. 100 centimeters make 1 meter. 50 centimeters is half of 100 centimeters. So 50 centimeters is half a meter. Half a meter is written as 0.5 meters. So 50 centimeters equals 0.5 meters. Fill in the blank. 0.89 meter. To convert meters into centimeters, multiply by 100. 0.89 meters means 89/100ths of a meter. Each 100th of a meter is 1 centimeter. So 0.89 meter equals 89 centimeters. Fill in the blank. 4 centimeters. 4 centimeters means 4/100ths of a meter. To write this as meters, write 4 over 100. 4 over 100 is 0.04. So 4 centimeters equals 0.04 meters. Fill in the blank. 325 centimeters. To convert centimeters into meters, divide by 100. 325 divided by 100 equals 3.25. So 325 centimeters equals 3.25 meters. Fill in the blank. 2.07 meters. To convert meters into centimeters, multiply by 100. 2.07 times 100 equals 207. So 2.07 meters equals 207 centimeters. Millimeter and meter. 1 meter is equal to 100 centimeters. 1 centimeter is equal to 10 millimeters. So 100 centimeters equals 100 times 10 millimeters. 100 times 10 is 1,000. Therefore, 1 meter equals 1,000 millimeters. So 1 millimeter equals 0.001 meters. Weight conversion. Kilograms and grams. 1 kilogram is equal to 1,000 grams. That means 1 gram is 1,000th of a kilogram. 1,000th written as a decimal is 0.001. So 1 gram equals 0.001 kilogram. Convert 5 grams to kilograms. To convert grams into kilograms, divide by 1,000. 5 grams means 5 over 1,000 kilograms. 5 over 1,000 is 0.005. So 5 grams equals 0.005 kilogram. Convert 10 grams to kilograms. To convert grams into kilograms, divide by 1,000. 10 grams means 10 over 1,000 kilograms. 10 over 1,000 is equal to 1 over 100. 1 over 100 is 0.01. So 10 grams equals 0.01 kilogram. It may also be written as 0.010 kilogram. Convert 254 grams to kilograms. To convert grams into kilograms, divide by 1,000. 254 grams means 254 thousandths of a kilogram. 254 over 1,000 is 0.254. So, 254 grams equals 0.254 kilogram. Part. Fill in the blank. 465 grams. To convert grams into kilograms, divide by 1,000. 465 divided by 1,000 equals 0.465. So, 465 grams equals 0.465 kilogram. Fill in the blank. 68 grams. To convert grams into kilograms, divide by 1,000. 68 grams means 68 over 1,000 kilograms. Since thousandths need 3 decimal places, we write 0.068. So, 68 grams equals 0.068 kilogram. Fill in the blank. 1,560 grams. 1,000 grams make 1 kilogram. 1,560 grams is more than 1 kilogram. To convert, divide 1,560 by 1,000. 1,560 divided by 1,000 equals 1.560. This can be written as 1.56. So, 1,560 grams equals 1.56 kilograms. Fill in the blank. 704 grams. To convert grams into kilograms, divide by 1,000. 704 grams means 704 thousandths of a kilogram. 704 over 1,000 is 0.704. So, 704 grams equals 0.704 kilogram. Fill in the blank. 0.56 kilogram. To convert kilograms into grams, multiply by 1,000. 0.56 times 1,000 equals 560. So, 0.56 kilogram equals 560 grams. Fill in the blank. 2.5 kilograms. To convert kilograms into grams, multiply by 1,000. 2.5 kilograms means 2 kilograms and 0.5 kilogram. 2 kilograms is 2,000 grams. 0.5 kilogram is 500 grams. So, 2.5 kilograms equals 2,500 grams. Milligram and gram. 1 gram is equal to 1,000 milligrams. That means 1 milligram is 1,000th of a gram. 1,000th, written as a decimal, is 0.001. So, 1 milligram equals 0.001 gram. Rupee and paise conversion. 1 rupee is equal to 100 paise. That means 1 paisa is 1/100th of a rupee. 1/100th of a rupee is written as 0.01 rupees. So, 1 paisa equals 0.01 rupees. Convert 75 paise to rupees. 75 paise means 75 hundredths of a rupee. To convert paise into rupees, divide by 100. 75 divided by 100 equals 0.75. So, 75 paise equals 0.75.
Fill in the blank. 10 paise. To convert paise into rupees, divide by 100. 10 paise means 10 over 100 rupees. 10 over 100 is 0.10, so 10 paise equals 0.10 zeros. Fill in the blank. 0.05 rupees. To convert rupees into paise, multiply by 100. 0.05 rupees means 5/100ths of a rupee. Each 100th of a rupee is 1 paisa. So 0.05 rupee equals 5 paise. Fill in the blank. 0.36 rupees. 0.36 rupees means 36 paise. The 2 digits after the decimal point in rupees show paise. So, 0.36 cents equals 36 paise. Fill in the blank. 0.50. 0.50 means 50 paise. It is also half of 1 rupee. So 0.50 equals 50 paise. Fill in the blank. 99 paise. 100 paise make $1. 99 paise is just 1 paise less than $1. As a decimal, 99 paise is 99 over 100 rupees. So 99 paise equals 0.990. Fill in the blank. 250 paise. 100 paise make $1. 250 paise contains 200 paise and 50 paise. 200 paise is $2. 50 paise is 0.50 zeros. So 250 paise equals $2.50. Locating 1.4 on a number line. The decimal 1.4 means 1 unit and 4 tenths. To locate it on a number line, look between 1 and 2. Divide the space between 1 and 2 into 10 equal parts. Then count 4 small parts after 1. The fourth small mark after 1 is 1.4. So 1.4 lies between 1 and 2 at the fourth tenth after 1. Naming divisions between 1 and 1.1. The space between 1 and 1.1 can be divided into hundredths. First, write 1 as 1.00. Then write 1.1 as 1.10. Now count by 100th each time. The numbers between them are 1.01, 1.02, 1.03, 1.04, 1.05, 1.06, 1.07, 1.08, and 1.09. Identifying decimals on a number line. Each small mark on a number line represents an equal step. To identify a decimal, first look at the labeled numbers. Then count how many equal parts are between them. Next, find the value of one small part. Finally, count from the nearest labeled mark. This helps us identify the decimal accurately. Zero dilemma. 0.2 and 0.20. Zeros added at the end of a decimal do not change its value. 0.2 means 2 tenths. 0.20 means 20 hundredths. But 20 hundredths is the same as 2 tenths. So 0.2, 0.20, and 0.200 all have the same value. Difference between 0.2, 0.02, and 0.002. Zeros between the decimal point and a non-zero digit change the value. In 0.2, the digit 2 is in the tenths place. In 0.02, the digit 2 is in the hundredths place. In 0.002, the digit 2 is in the thousandths place. Tenths are larger than hundredths. Hundredths are larger than thousandths. So 0.2 is greater than 0.02, and 0.02 is greater than 0.002. Same values among 4.5, 4.50, and 4.50. Zeros at the end of a decimal do not change its value. A zero before a whole number also does not change its value. So 4.5 is equal to 4.50, and 4.50 is also equal to 4.50. But 4.05 is different because the digit 5 is in the hundredths place. Also, 4.050 is equal to 4.05. So 4.5, 4.50, and 4.50 are equal. And 4.05 and 4.050 are equal. Locating 4.185 by magnifying number lines. To locate 4.185, we use repeated zooming on the number line. First, locate the number between 4 and 5. Next, zoom in between 4.1 and 4.2. Then zoom in between 4.18 and 4.19. The number 4.185 lies halfway between 4.18 and 4.19. So 4.185 is halfway between 4.18 and 4.19. Creating number lines for 9.876. To locate 9.876, zoom in step by step. First, locate it between 9 and 10. Then locate it between 9.8 and 9.9. Next, locate it between 9.87 and 9.88. The number 9.876 is 6 thousandths after 9.870. So 9.876 lies between 9.87 and 9.88. Creating number lines for 0.407. The decimal 0.407 is less than 1, but it can still be located on a number line. First, locate it between 0 and 1. Then zoom in between 0.4 and 0.5. Next, zoom in between 0.40 and 0.41. The number 0.407 is 7 thousandths after 0.400. So 0.407 lies between 0.40 and 0.41. Number line from 5 to 10. Suppose the interval from 5 to 10 is divided into 10 equal parts. The total distance from 5 to 10 is 5 units. Now divide 5 units by 10. 5 divided by 10 equals 0.5. So each small division is 0.5. The middle mark between 5 and 10 is 7.5. Comparing 6.456 and 6.465. To compare decimals, compare the digits from left to right. Both numbers have 6 in the ones place. Both numbers have 4 in the tenths place. Now compare the hundredths place. In 6.456, the hundredths digit is 5. In 6.465, the hundredths digit is 6. Since 6 hundredths is greater than 5 hundredths, 6.465 is greater than 6.456. Why we stop at the first different digit. When comparing decimals, we stop at the first place where the digits are different. This is because higher place values are more important than lower place values. For example, if two numbers first differ in the hundredths place, then the thousandths place cannot change which number is larger. So compare from left to right. Stop at the first different digit. The number with the larger digit in that place is greater. Compare 1.23 and 1.32. Both numbers have the same whole number part, 1. Now compare the tenths. In 1.23, the tenths digit is 2. In 1.32, the tenths digit is 3. Since 3 tenths is greater than 2 tenths, 1.32 is greater than 1.23. Compare 3.81 and 13.800. When comparing decimals, look at the whole number part first. The whole number part of 3.81 is 3. The whole number part of 13.800 is 13. Since 13 is greater than 3, 13.800 is greater than 3.81.
Compare 1.009 and 1.090. Let us compare 1.009 and 1.090. Both numbers have 1 in the ones place. Both numbers have 0 in the tenths place. Now compare the hundredths place. In 1.009, the hundredths digit is 0. In 1.090, the hundredths digit is 9. Since 9 hundredths is greater than 0 hundredths, 1.090 is greater than 1.009. Closest decimal to 1. To find the number closest to 1, compare the distance of each number from 1. The distance from 0.9 to 1 is 0.1. The distance from 1.1 to 1 is also 0.1. The distance from 1.01 to 1 is 0.01. The distance from 1.11 to 1 is 0.11. The smallest distance is 0.01, so 1.01 is closest to 1. Closest to 1.09. To find the number closest to 1.09, compare distances. The distance from 1.1 to 1.09 is 0.01. The distance from 1.11 to 1.09 is 0.02. The distance from 1.01 to 1.09 is 0.08. The distance from 0.9 to 1.09 is 0.19. The smallest distance is 0.01, so 1.1 is closest to 1.09. Closest to 4. To find the number closest to 4, compare the distance of each number from 4. 4 minus 3.56 equals 0.44. 4 minus 3.65 equals 0.35. 4 minus 3.099 equals 0.901. The smallest distance is 0.35, so 3.65 is closest to 4. Closest to 1. Let us compare 0.8, 0.69, and 1.08. The distance from 0.8 to 1 is 0.2. The distance from 0.69 to 1 is 0.31. The distance from 1.08 to 1 is 0.08. The smallest distance is 0.08, so 1.08 is closest to 1. Addition of decimals. Begins. Priya needs 2.7 meters of cloth. Shilaja needs 3.5 meters of cloth. To find the total cloth needed, add 2.7 and 3.5. 2.7 means 2 meters and 7 tenths. 3.5 means 3 meters and 5 tenths. Add the whole meters. 2 plus 3 equals 5. Add the tenths. 7 tenths plus 5 tenths equals 12 tenths. 12 tenths is 1 whole and 2 tenths. So, 5 plus 1 and 2 tenths equals 6 and 2 tenths. Therefore, the total cloth needed is 6.2 meters. Subtracting decimal lengths. Now let us find how much longer 3.5 meters is than 2.7 meters. We need to subtract 2.7 from 3.5. 3.5 means 3 meters and 5 tenths, but 5 tenths is smaller than 7 tenths, so we borrow 1 meter. 1 meter is equal to 10 tenths, so 3.5 becomes 2 meters and 15 tenths. Now subtract. 15 tenths minus 7 tenths equals 8 tenths. 2 meters minus 2 meters equals 0. So, the difference is 0.8 meter. Aligning decimal points. When adding or subtracting decimals, always align the decimal points. This keeps units under units, tenths under tenths, hundredths under hundredths, and so on. If needed, add zeros to make the number of decimal places equal. Then add or subtract place by place. Finally, bring the decimal point straight down into the answer. So the rule is, always align decimal points before adding or subtracting decimals. Adding 75.345 and 86.691. Let us add 75.345 and 86.691. Both numbers have 3 decimal places, so we align the decimal points. Start from the thousandths place. 5 plus 1 equals 6. Now the hundredths place. 4 plus 9 equals 13. Write 3 and carry 1 to the tenths place. Now the tenths place. 3 plus 6 plus the carried 1 equals 10. Write 0 and carry 1 to the ones place. Now add the whole number parts. 75 plus 86 plus the carried 1 equals 162. So, 75.345 plus 86.691 equals 162.036. Subtracting with decimals. Decimal subtraction may need borrowing. First, align the decimal points. Next, add zeros if needed, so both numbers have the same number of decimal places. Then subtract from right to left. If a digit is too small, borrow from the place to its left. Finally, bring the decimal point straight down. Decimal subtraction uses the same borrowing method as whole number subtraction. Decimal addition in money. Money often uses decimals. For example, 2 rupees 45 cents means 2 rupees and 45 paise. The whole number part shows rupees. The decimal part shows paise. Since 100 paise make 1 rupee, paise are hundredths of a rupee. So 2 rupees 45 cents means 2 rupees and 45 paise. Decimal addition in measurements. Measurements often use decimals because objects may not measure whole units. For example, let us add 1.3 centimeters and 0.9 centimeter. Align the decimal points. Now add the tenths. 3 tenths plus 9 tenths equals 12 tenths. 12 tenths is 1.2. So 1.3 plus 0.9 equals 2.2. Therefore, 1.3 centimeters plus 0.9 centimeter equals 2.2 centimeters. Decimal subtraction in measurements. To subtract decimal measurements, add zeros if needed. For example, 1.3 can be written as 1.30, and 0.9 can be written as 0.90. Now subtract. 1.30 minus 0.90 equals 0.40. 0.40 is the same as 0.4, so the difference is 0.4. Decimal multiplication by 10. Multiplying by 10 makes a number 10 times bigger. Each digit moves to a place with 10 times more value. Tenths become ones. Ones become tens. Tens become hundreds. For example, 0.5 times 10 equals 5. 2.34 times 10 equals 23.4. 0.07 times 10 equals 0.7. So, multiplying by 10 shifts the digits one place to the left in value. Decimal division by 10. Dividing by 10 makes a number 10 times smaller. Each digit moves to a place with 10 times less value. Ones become tenths. Tenths become hundredths. Hundreds become tens. For example, 5 divided by 10 equals 0.5. 23.4 divided by 10 equals 2.34. 0.7 divided by 10 equals 0.07. So, dividing by 10 shifts the digits one place to the right in value. Fractions to decimals, 5/100ths. A fraction with denominator 100 can be written directly as hundredths. 5/100 means 5/100ths. Hundredths are written in the second place after the decimal point. There are no whole units, so write 0 before the decimal point. There are no tenths, so write 0 in the tenths place. Then write 5 in the hundredths place. So, 5/100 equals 0.05. Fractions to decimals, 16 thousandths. 16/1000 means 16 thousandths. Thousandths are written using 3 places after the decimal point, so we write 0.16 after the decimal point. Therefore, 16/1000 equals 0.016. Part 158. Fractions to decimals, 12 tenths. 12/10 means 12 tenths. 10 tenths make 1 whole. So, 12 tenths is 1 whole and 2 tenths. 2 tenths is 0.2. So, 12/10 equals 1.2. Fractions to decimals, 254 thousandths. 254/1000 means 254 thousandths. Since the denominator is 1000, the decimal must have 3 digits after the decimal point. So, 254 thousandths is written as 0.254. Decimal-like notation in cricket. In cricket, 5.5 overs does not mean 5.5 in the usual decimal sense. Decimal numbers are based on 10. But cricket overs are based on 6 balls. 1 over has 6 balls. So, 5.5 overs means 5 overs and 5 balls. It does not mean 5 and 5/10ths overs. So, cricket over notation is not true decimal notation.
History of decimal notation. Decimal fractions developed over time. Mathematicians and astronomers needed accurate ways to write small quantities. Decimal notation made calculations easier because it followed the place value system based on 10. The decimal point was not always written in the same way. Different people used different marks before modern notation became common. So, decimal notation became useful because it made small parts easier to write and calculate. Decimal point and decimal comma. Some countries use a comma instead of a decimal point. For example, some places write 1.5 as 1,5. The symbol changes, but the meaning stays the same. Both the decimal point and the decimal comma separate the whole number part from the fractional part. The place values of the digits remain the same. So, The notation symbol may differ, but decimal place value stays the same. Final summary: tenths, hundredths, and thousandths. Decimal numbers represent parts of a whole using powers of 10. A tenth is 1 part out of 10. A hundredth is 1 part out of 100. A thousandth is 1 part out of 1,000. Each place to the right of the decimal point is 10 times smaller than the place before it. Remember, 1 over 10 equals 0.1. 1 over 100 equals 0.01. 1 over 1,000 equals 0.001. 10 hundredths make 1 tenth. 10 tenths make 1 whole. So each decimal place to the right is 10 times smaller. Final summary: operations with decimals. Addition and subtraction of decimals follow place value. Decimal operations are not completely new methods. They use the same place value ideas that we use with whole numbers. The decimal point helps us align the correct places. To add or subtract decimals, align the decimal points. Add zeros if needed. Add or subtract from right to left. Regroup or borrow when needed. Then place the decimal point correctly in the answer. So, decimal operations are solved place by place. Final student revision. Decimals are useful in measurement, money, weight, number lines, comparison, addition, and subtraction. Decimals help us describe quantities that are not whole numbers. They are useful when measuring small lengths, converting units, writing money, comparing numbers, and solving real-life problems. By the end of this chapter, you should be able to read decimals correctly. You should be able to write tenths, hundredths, and thousandths as decimals. You should be able to compare decimal numbers. You should be able to locate decimals on a number line. You should be able to convert millimeters to centimeters, centimeters to meters, grams to kilograms, and paise to rupees. You should also be able to add and subtract decimals by aligning decimal points. To master decimals, understand place value first. Once place value is clear, measurement, comparison, and operations become much easier.
See you then. I will be ready and waiting for the next part of A Peek Beyond the Point. I'll keep the gears turning and make sure to have that good writing queued up for when you return.